Hey everyone, Mr. Skelton here, back at it, Lesson 8, Unit 4, and today we're going to be talking about the rational root theorem. If you look at all the problems in today's video notes, we're still solving. Every single slide says to solve, and so that should make you feel confident, right? We've been solving polynomials. How have we been solving? We've been using our graphing calculator, all right? We've been factoring. We've been using long and synthetic division, right? And those have really been the methods that we've been doing. We've seen the quadratic formula kind of come back into play a little bit recently, and don't forget about imaginary numbers when we take the square root of a negative. So all those things are kind of coming back into play. So you may be wondering, maybe you're not, but what is the rational root theorem and why did mathematicians decide to use the rational root theorem? So the reason we use the rational root theorem is if we don't have technology or the graphing calculator. Okay, so before graphing calculators were even in existence, or before the technology was there to just graph, right? Because graphing's nice. You can put it in your graphing calculator, see where it crosses the x-axis. That will give you a solution, and then you can factor and use all these different ways to find the rest of your zeros. Well, what if we didn't have the graphing calculator? How would you be able to tell or find or solve your solutions for polynomials? Okay, and so that's what the rational root theorem is. So what are we going to do today? Here's what mathematicians had to figure out. They had to figure out testing possibilities. Okay, they had to figure out a way to test possible solutions using synthetic division, okay, to see if they could get zeros, which are our solutions, right? And so what I'm going to show you today is how mathematicians came up with all these possible answers and then how to test them using synthetic division. Rational, what does rational mean? Rational means just a fancy word for a fraction, okay? So what mathematicians wanted to do was test possible fractions. They could also reduce to get you nice, neat integers, right? Like 4 over 2 is a fraction, but that's really just 2. So we can test numbers like 2, but we could also test answers like a third or 4/5 or something like that. All right, so that's what we're trying to do today. We're trying to come up with possible zeros, and we're going to test them using synthetic division to see if they work without using the graphing calculator. So I'm going to show you kind of how mathematicians came up with the rational root theorem before we actually start using it, so that you can maybe see how this works. So here's a quadratic, because it's squared, and it says to solve by factoring. So this is a situation where our leading coefficient is something other than 1. So I would be using the box method here. You can use whatever method you learned in Algebra 1. So 2x squared there, minus 2, so I'm going to have a minus 4. That's going to be a positive 4 and a negative 1, because 4 times negative 1 is negative 4. 4 minus 1 is 3. Put our x's in there, going across 2x, going across negative 1, because that box is negative. Going up is x, and going up is 2. And so this factors into 2x minus 1 and x plus 2. Now, this says to solve, so that's set equal to 0. So we would say 2x minus 1 equal to 0, x plus 2 equal to 0. And I'm going to actually put a 1 in front of this x just for demonstration purposes, and I can kind of show you how we get to these testing points. So solve this, so 2x would equal 1 divided by 2, and x would equal 1/2. And I would subtract 2 and get 1x equals negative 2. I'm going to divide by 1 again. I'm going to leave my answer in a fraction, even though I would never ask you to do that, but just for demonstration purposes. Okay, so here's what mathematicians started to figure out. They found some patterns. A lot of math is pattern recognition, and here's one of the patterns that they figured out. I want to focus on the denominator of our answers, of our solution. I'm going to just circle it with a pencil. This 2 came from this 2 right here, which came from this 2 right here, okay, which came from this 2 right here, and this 2 is a factor of our leading coefficient, right? Let's jump over here. Let's look at the denominator in this answer. 1, where'd that 1 come from? It came from right here, and then it came from here, and there's really a 1 in front of there, and that came from there. And what is that? That 1 is a factor, okay? Factor of our leading coefficient. And then mathematicians notice this. I'll use red. Let's look at the numerator of our answers, and I'll kind of put a box around it. That negative 2 came from here, which came from there, which came from there when I added it, and that came from here. This 2, if you go back to how we broke this down, is a factor of 2, or negative 2. Let's look at the numerator here. 1 came from here, which came from here, and that came from also here. And so those are our factors. Those numbers are factors of our last term. Okay? And so what mathematicians discovered was they could figure out possible zeros by taking all the factors, okay, of, if you notice, the last term's factors are on the top. So I'm going to just, we usually in textbooks write it as P, you see it in textbooks a lot as P over Q. So this P represents factors of your constant term. And when we say factors, we're going to include positives and the negatives, so plus or minus factors of the last term, so 2, divided by our factors of our leading coefficient, which is our 2. This is the rational root theorem. Okay? We're going to find all the possible zeros by taking all of the factors of this number divided by all the factors of our leading coefficient, and we're going to test those using synthetic division. So let's try it. So kind of have a pretty challenging one to start with. Let's try one that's a little bit easier. Let's actually go down to the bottom here and try this one, because the one above it is pretty tough. So what we want to do then is, again, we don't have a graphing calculator. If we did, it'd be just easy. We'd throw this in, we'd hit graph, and we'd look where it crosses the x-axis, and we'd find our zeros. But we don't have that luxury. So what we're going to do here is we're going to take all of the possible factors of 1. And again, we're going to try to give you some ones that aren't too bad. So what are all the possible factors? If we go P over Q, that's going to give us plus or minus 1 divided by all the factors of 2. What are the factors of 2? Plus or minus 1 and 2. So if you were to write all these out, it would be like, you know, positive 1 over positive 1, which is a 1 we could test. We could test negative 1. We could test 1/2, and we could test negative 1/2. And really, those are all the factors that we could have, right? 1 over 1, negative 1, 1/2, and negative 1/2. These are all the possible zeros to this answer. So let's test one. Let's just pick positive 1. So what we're going to do is pick 1, and we're going to test it using synthetic division. So we got 2, negative 1, 2, and negative 1. And we'll just do synthetic division. 2, that gives me a 2, 1, 1, 3, 3, 2. Okay, so what does that mean? We've been talking about this. What is that? That's a remainder. So what do we know? We know that this possible 0 of 1 is not a 0. It's not going to work because we have a remainder. So that doesn't work. So mathematicians, again, before technology, they had to try the next possible 0. So let's try negative 1. 2, negative 1, 2, negative 1, right? 2, negative 1, 2, negative 1. Squiggly line, drop down. So I got a 2, negative 2, negative 3, 3. I have 5, and negative 5, negative 6. Still not working, okay? So what does that mean? That means that that's not an answer. So what do we have to try? Let's try 1/2. So I got 1/2. Got 2, negative 1, 2, negative 1. Let's drop down. 2. Half of 2 would be 1, right? 1 plus 1, negative 1 and 1 would give me 0 times 0. 2 and 0 makes 2. 1/2 times 2, 1, 0. Winner. So I know, because my remainder is 0, that this is a 0. Check mark. I know right now, because it says to solve, that x equals positive 1/2 is one of my 3 solutions. How do we find the other two? Well, remember what you have right here. This becomes your constant. That's your x squared. So you basically have 2x squared plus 2 left over. Okay? Well, how do we solve that for x? We could do this a couple different ways. We could just set this equal to 0. You could factor out a 2, or I'm just going to solve this for x squared. I'm going to, because there's no other x value, right? 0x squared. So I'm going to subtract 2. I'm going to get 2x squared equals negative 2. Divide by 2. I get x squared equals negative 1. Square root, and I get x equals plus or minus I. And there's your other two solutions. So there's a situation where I could use some square rooting. I could have factored this, right? I could have taken out a 2 and had x squared plus 1 equal to 0 and solved that by factoring. So that's solving by factoring. I could have used the quadratic formula. You don't really need to, but we talked about this in our unit over quadratics, where we figure out what's the best method to solve the quadratic. Because that's just x squared, I did square rooting, but you could have used the quadratic formula if you wanted to, okay? I'm going to go ahead and just continue to skip that top slide just because it's a little nasty. I'm not going to solve it, but I am going to do this with you. I'm not going to solve this one, but let's just talk about what our possible zeros would be for this solution. So if we're just talking, if I asked you not to solve and I just said list the possible rational zeros, we would go P over Q, this being our P, this being our Q, and we'd go all the factors of 6 plus or minus. So we usually write just the plus or minus sign in front. What are the factors of 6? We got 1, 2, 3, and 6 over all the factors of 24, plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. So there's a lot, right? So think about all the different combinations of test points that you would have to pick. Now, if I say on a quiz or test, list all the possible rational zeros, you don't have to go ahead and simplify this. I would accept this as your answer right here, because this is a good enough list for us. You don't have to go 1 over 1, negative 1, positive 1/2, negative 1/2, 2/3, positive 2/3. You don't have to write everything out. If you write it just like this, that'll work, okay? All right, so I want you to go ahead and hit pause and try to solve this one on your own. Notice I got some nice smaller numbers here for you so that you can try some things and see what you come up with. Okay, so let's take a look at it here. Again, we want to list all of our possible zeros. We don't have a calculator to use on this, so here's all my P values. 3 is my Q, so if I go P over Q, I'm going to have plus or minus 1. Those are the only factors of 1 over the factors of 3, which are 1 and 3 only. So when I have a small list like this, I can write it out. 1, negative 1, 1/3, and negative 1/3. Those are my testing zeros. Those are all my possible rational roots, is what we call them, our rational roots that we can test. So let's test them. I'm going to try negative 1. Since I had no luck with it last time, let's try it this time. So I'm going to have 3, 1, negative 1, and 1. Those are my synthetic division numbers here. Drop down to 3, negative 3, add negative 2, 2, 1, negative 1. Look at that. Perfect. Love it. So what do I know? Well, I got a remainder of 0. That's a good thing. That means this 0 of x equals negative 1 is a winner. That is a solution. I got 3 solutions, right? Because my highest degree is a cubic. This is a cubic function. So I know I'm going to have 3 solutions. So I got one of them. What do I do with what's left under synthetic division? Constant x squared. So I got 3x squared minus 2x plus 1. Now, if I was doing this, I would go ahead and box method this. Let's see if it factors. 3x squared and 1 make 3. Now, there are two numbers that multiply together that give you 3. Add together, you get negative 2. Let's see, 3 and negative 1. Nope, because they gotta multiply to make a positive 3. So negative 1 and 3. Nope. This doesn't factor, right? I can't find any combination of 3 that makes negative 2. So what does that mean? That means that this is not factorable, which probably means, not probably, which means that my other 2 solutions are going to be imaginary. So what method do you want to solve here, this quadratic? What method do we want to use? My guess is, hopefully you're saying, the old quad formula, okay? So my a value is 3, my b value is -2, my c value is 1. So let's do it. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to get +2 plus or minus. That's going to be 4. I'm going to have 4 minus 12. So I'm going to have a -8 all over, see, that was a 3. So 2 times 3 is 6. So we got to break down -8, right? That's going to go 4 and 2. So that's going to be 2i radical 2. So I'm going to have 2 plus or minus 2i radical 2 all over 6. And then because we talked about this in class the other day, because that's even and that's even and that's even, I can write my final answer as 1 plus or minus 1i, or just I, radical 2. So there's 2 solutions. There's your third solution, and that's how you use the rational root theorem. Okay? This can be a little tricky, so if you have questions, or if I know some of you may have some questions, I'd be happy to go through some of these notes with you again, reteach it, slow down for you, maybe do a couple more examples, and then hopefully we can get the hang of it pretty quick. Okay? Take care.